Hi dear students, with this presentation we will be starting our third module, and the third module is basically consisting of the energy produced by using the wind, okay, or it is related to the wind energy, how the wind energy is converted into electricity, and we will be finally discussing about the economics of the wind power, okay. So as an introduction to the topic, we will first look into the topic introduction to the wind. So what is wind? Wind is actually atmospheric air in motion. That all of us know. Wind is actually the atmospheric air in motion. So how this motion is caused is by the difference in the atmospheric pressure. Actually, this motion of the air is due to the pressure difference. If some area we are having higher pressure and the other area we are having lower pressure, of course the fluid will flow from higher pressure region to the lower pressure region. So that basic pressure difference is the cause for the motion of the air, or simply that is the reason for the wind formation, okay. When a difference in atmospheric pressure exists, air moves from higher to the lower pressure area, resulting in winds of various speeds. So how much pressure difference exists, that will determine the speed of the wind, okay. So now we will be very much interested to know how that pressure difference is created. Actually, pressure is directly related to the density. So the two major driving factors of wind patterns are the differential heating between the equators and poles, and the other one is rotation of the planet. These two are the main reason for the formation of the wind. That is, first one is differential heating between the equator and the poles, which means in the equator we will have the higher solar radiation. Equator will be receiving the areas in the vicinity of the equator will have more solar radiation compared to the places at the poles. So the temperature at the near the equator will be much higher compared to the temperature at the poles. That already we are knowing. That is the reason why the ice cubes are there in the both north pole as well as the south poles. The reason is the low temperature existing there. Now the second reason is rotation of the planet. Now we know each second the sun releases an enormous amount of the radiant energy into the solar system. So some amount of that solar energy is reaching the earth also. Some of it reaches the earth, strikes the equator directly. See, the equator region is getting more solar energy compared to the polar regions, okay. So giving it the most solar radiation. So most of solar energy is striking in the equator region, whereas the diffused radiation is more reaching the polar regions. So there is no direct solar insolation into the polar regions. So that is the reason why the temperature at the polar region is very less. Diffuse along the north and southern hemisphere, the poles receive the lowest amount of radiation. So the highest amount of radiation is received at the equator, and lowest amount is received at the both the poles, north pole as well as the south pole. So moving away from the equator means the radiation availability will be less. So where we are having more solar radiation, of course the temperature is expected to be high, and where we have the lowest solar radiation, there we will have the lowest temperature. So one more thing we directly know is density of the fluid is always inversely proportional to the temperature, which means if the temperature increases, the density is going to be decreased. So if we connect this fact with the earlier one, that is at the equator we will have the more solar radiation, that means the temperature of the places near to the equator will be much higher compared to the polar region. So density of the air at the equator region will be less compared to the density of the air at the polar region. So of course due to that density difference, there will be a pressure change, okay. So lesser density air will be moving upward, whereas to that vacant space higher density air particle will be coming, or cooler air will be coming to fill that space left by the lower density air. So the lesser density air will be moving upward, lower density air will be coming into that place. So if there is a temperature difference between two places, so which place is having higher temperature, the air density will be less, whereas the place where temperature is less means there we will have the cool air, or the density will be higher. So this lesser density air will be moving upward, it is replaced by the higher density air from the cold place. So there will be a continuous movement of the air. That is what is known as wind. So wind is broadly classified into two, that we will see in the next slide. That is one is called planetary winds, and the other one is called the local winds. So if the difference between, or if the distance between the places, or the wind is traveling for a short distance, then it is, we will call it as, simply we will call it as local wind, just like the difference in the temperature between sea and land. that will cause for the movement of the air. That is what is known as local wind. But whereas planetary winds are usually caused by the movement of the planet itself, or the movement of the earth itself, and the air traveling, the distance traveled by the air in this case will be very large, as well as the power of the wind will be more in the planetary cases. Okay, so anyway, we will be discussing it in detail. Wind is formed due to the phenomenon called the Coriolis effect. The Coriolis effect is actually the tendency for any moving body or on or above the Earth's surface to drift sideways from its course because of the Earth's rotation. See, the Earth is continuously moving. So, because of the movement of the Earth, all the objects in the Earth will have a drift to move sideways. See, you imagine the Earth is moving around a particular central road connecting the two poles. So what happens is the equator will have the most diameter, whereas poles the diameter will be 0, approximately 0. So a particle placed at the equator, that means at the north pole, either at north pole or south pole, sorry, not equator, a particle placed at south pole or north pole has to cover a very small distance during this 24-hour time, that is in a day, whereas the particle at the equator will have to move a very long distance, that is through the periphery of the earth. Okay, so that is a very large distance, so it has to cover that much distance within that 24-hour time. So both the particle is covering taking the same time, that is 24 hours, but the distance traveled by the particle at the poles are much less compared to the a particle placed at the equator. So the velocity, of course, the velocity of the particle at the equator is going to be very high compared to the velocity of the particle at the poles. Of course, if it is exactly at the pole, then we can say the velocity is 0. So there is a relative velocity concept. If the Earth is stationary, then see in this figure, if the Earth is stationary, it is not moving, then what happens is the here equator region, at this region they will have the higher temperature. Here both the ends, that is at the pole, here this is north pole, this is south pole, so both the poles will have the low temperature, so the air will be moving always from the equator region towards the polar region. Hot air will be moving from this side to that side. That vacant space is replaced by the air movement from the polar side towards the equator. So this long distance traveling of the air is actually known as planetary wind. Okay, so if the air is not moving, if the earth is not moving, then air can freely move from equator to polar region along a straight line. But what happens when the earth is rotating, the air direction is also getting diverted. So just like the relative velocity concept, see, if you want to strike the ball on a moving particle, then where we want to say, if you throw the balls directly into that particular point where we want to strike in a straight line, then it won't strike because the other particle is moving. So we had to throw the ball in a particular angle so as to strike in the exact position. Okay, that depends on the velocity. Same thing is happening here also. See, the equator region, since the earth is moving, equator region will have the more velocity. So if you want to strike at the pole, then actually air has to move along a curved path. That is what is happening in the actual case. If the earth did not rotate and remain stationary, the atmosphere would circulate between the two poles. Two poles means high pressure area and the equator. Equator is actually the low pressure area. Since the temperature is high, the pressure at the equator will be low. At the poles, we have the low temperature, that means the density is much more, that means pressure will be high. So if the earth did not rotate and remain stationary, the atmosphere would circulate between the poles and the equator in a simple back and forth pattern. Actually, air can move in a straight line manner, that is what is the meaning. But because the earth rotates, circulating air is deflected. Instead of circulating in a straight pattern, the air deflects towards the right in the northern hemisphere and towards left in the southern hemisphere, resulting in a curved path. This curved, the air is moving, instead of moving in a straight line because of the rotation of the earth, actually air will be moving in a curved path. That effect is actually known as the Coriolis effect. Okay, there is no need to know much about this concept. Those who are interested, you can study through online, you can search in Google and all, you can find the what is Coriolis effect and all. Anyway, this is one major reason for the planetary air movement. See, this picture somewhat shows the movement of the air in both. If the earth was stationary, this thing will happen. Air will be moving along a straight line from the equator to the polar region, and there will be coming the higher density air or cool air will be coming in the opposite direction. Both will be in a straight line, but here, since the earth is moving, actually air will be traversing a curved path to reach the polar region, and the higher density air or cool air from the pole will be coming in the opposite direction along the same curved path. Okay, so anyway, the path will be curved in the case of planets which is rotating about its own axis. Okay, just like earth. Okay, now coming to the sources of the wind. Wind are natural phenomena in the atmosphere and have two different origins. See, these are the two different sources of energy. First one is source of wind. First one is planetary wind, and the second one is local wind. So planetary winds are caused by solar heating of the Earth's surface near the equator than near the north or south poles. As I have already told, the equator region will be receiving more solar energy, so the temperature is expected to be high. So pressure will be less there. Whereas north and south poles will have the low solar intensity, so the pressure will be high. Okay, this causes warm tropical air to rise and flow through the upper atmosphere towards the poles, and cold air from the pole to flow back to the equator nearer to the earth's surface. Okay, so hot air will be moving through the upper atmosphere, and the cold air will be flowing through the lower atmosphere. So this circulation of the air from equator to pole and from pole to equator is what is known as the planetary winds. Actually, this movement is caused by the rotation of the planets, and the path followed by the air is a curved path. Okay, the direction of the motion of the planetary wind is affected by the rotation of the earth. See, the direction of the motion of these types of winds are affected by the rotation of the earth. The second type of wind is called local winds. Local winds are caused by unequal heating and cooling of the land and water, and also by hills and mountain sides, etc. Okay, see, we have a land, and nearby we are having a sea or something like that. Water is available. So of course, the absorption capacity will be different. In the daytime, the land will be absorbing more radiation energy, and the land will be more hotter compared to the water. But whereas in the night time, the reverse thing will be happening. The water will be releasing more energy, whereas the land will be cold compared to the water. So to and from motion of the air will be there from land to water, as well as from the water body to the land. Okay, that depends on the temperature. In morning time, daytime, the land will be more hot. That means the lesser density air is at the land side, whereas higher density air is at the water side or sea side. So air will be flowing from sea side towards the land, as well as the lesser density air will be moving from land towards the seaside. Okay, the reverse will be taking place in the night. Okay, so these types of wind produced by the local temperature difference is known as local winds. Another reason for this local temperature difference is mountains. See, some mountains are there. One side of the mountain we will have the different temperature compared to the other side of the mountain. നമുക്കത് എക്സ്പീരിയൻസ് ചെയ്യാൻ പറ്റും. കേരളത്തിലെയും തമിഴ്നാട്ടിലൊക്കെ കണ്ടീഷൻസ് വെച്ചിട്ട് നമുക്ക് എക്സ്പീരിയൻസ് ചെയ്യാൻ പറ്റും. ഓക്കെ, so such temperature difference in local areas will cause for the local movement of the air. That is what is known as the local winds. Now coming to the advantages of wind energy. These are the main advantages of wind energy. All the advantages are known to you. Okay, write the answers according to the question. Okay, marks awarded for the question. If it is of higher mark, then you have to elaborate this one. The main advantages of the wind energy is, first one, it is availability is free. Okay, wind blows day and night, which gives wind turbine the ability to produce electricity at all hours of the day. See, in compared to solar power plants or solar energy conversion, the energy production is possible only during the availability of the sunlight. So at daytime only we can produce the energy, but here we can produce the energy at any time. Whenever wind energy is available, we can produce the power, and it is freely available. Though no such conversion, everything is required. It is free form of energy available. And the next advantage is clean. It is one of the cleanest form of energy compared to the other one. Wind energy is the renewable source of energy that generates no pollution, unlike fossil fuels such as coal or natural gas. We know the fossil fuels and natural gas are producing lot of atmospheric emissions, but here this source of energy, just like the solar energy, here the wind energy is also a clean source of energy. The third one is cheaper. Wind energy is one of the lowest prices renewable energy technologies available today, costing between 4 to 6 cents per kilowatt hour. Okay, so one of the cheapest energy, but of course, coming to the disadvantage, the structure is very high, massive, and initial cost is very high. So that's why not that much popular compared to the solar energy. But still, some countries are giving priority for the wind energy rather than the solar energy. Now next is placeability. See, by introducing the wind energy systems, the place lost is very less. See, for the introduction of the solar energy, we require a very large area, and that place cannot be used for any other purpose. But here, coming to the wind energy, placeability is the important advantage. Farmers can also still continue to use the land due to the turbines only taking up the fraction of the land. So only very small fraction of the land is utilized for the installation of the wind turbines. So the most of the land can be utilized for the cultivation and all. So placeability is very high compared to the other energies. Now the next one is domestic, can be used as a domestic energy. Since the size of the wind turbine can be of different, can be reduced, or in that fashion we can install the wind turbines even in the backyards and all. So for the small purpose and all, we can use small models, small sized wind turbines can be used, can be of small size too, so can place anywhere. So that is used for the domestic purpose also. We can utilize this one for the domestic purpose as well as. And the last advantage is remote area supply. See, this is best to supply the energy at the remote areas. See, the remote areas, usually the hilly areas, will have the plenty availability of the wind energy. So in that area, this wind turbines are the, or wind energy is the best suitable energy to harvest the energy. Now coming to the disadvantages of the wind energy, efficiency of the wind turbine depends on the wind speed. As we know, the availability of the wind speed is varying, so it inversely is depending, efficiency of the wind turbine is depending on the wind speed, means we cannot produce much efficiency from this one. So that is the major disadvantage. Even if season to season, even if from season to season, sometimes wind speed can change. At that time, if the no wind is available, that means we cannot produce the power also. But as far as comparing to the solar energy, in the case of solar energy, at least some solar energy is available at any day. Okay, so even though fluctuation will be there in the intensity of the solar energy, but still solar energy is most of the time it is available, but we cannot assure the availability of the wind. That is the main disadvantage. Then comes the noise problem. Some people find it annoying, and if it is close to a house, it may lead to the sleeplessness and on to anxiety and stress for some individuals, which could lead to the health issues. So it is creating very high noise, so that is not adjustable for the human being, so that may create some problems, health issues and so can be there. Now coming to the third disadvantage, even though the cost of wind power has decreased dramatically in the past 10 years, the technology requires a higher initial investment than the fossil fuel generators. See, the initial investment required in the case of wind energy is much high compared to the fossil fuel generators. Of course, the solar is having the same problem. That is the disadvantage with most of the renewable source of energy. Fossil fuel is now that much popular only because of it. It is initial cost is very less, and for unit power production the cost will be less. That is the advantage of fossil fuel generators. But we can hope within the 10 or 20 years the things will change. Okay. Now coming to the next disadvantage, power density is very low. Needs a very large number of windmills to produce modest amount of power. If you want to produce the power in a large amount, then we have to install very large windmills, which is very costly. Cannot meet large scale and transportation energy needs. See, with this power production, we cannot meet the large scale and transportation energy needs. That is another disadvantage as far as wind energy is concerned. Coming to the environmental problems, wind turbines kills birds and bats. That of course the birds are flying through the heights. Wind turbines are also erected into a very high, into a very height, so there can be destruction of the birds and all, destruction of native vegetation, erosion problems. All these are the environmental problems. and also along with this, fires in the wind turbine, which happens very rarely only, but if it happens, then it is extremely difficult to fight. See, that much massive is the structure of wind turbines. So if fire and all happens, then it will be very difficult to handle. That are all the disadvantages compared to the disadvantages of the wind energy. Okay, thank you.